This is homework lesson 4.1. For this exercise, show you here, bottom here, you're going to draw a path. We're going to draw a path from point A to point B. These circles on the plan are trees, so when you're drawing in the path, the idea is to save as many trees as possible. In other words, don't go through the trees here, go around down to the bottom. It goes from the bottom 32.9 up to 38.2. You need to draw a 6-foot wide path. In the book, they said they gave you a longitudinal slope, but that meant that you have to draw the path and get it exactly the right length. I think it's easier. You guys just draw on the path, you measure it, calculate what the longitudinal slope is, and put that here. You decide what the longitudinal slope is going to be. The cross slope of the path is 2%, and the maximum slope is 4:1. That means your contours have to be at least 4 feet apart when you tie back in. Calculate the total length of your path. You need to do that to determine the longitudinal slope, site path to avoid existing trees, and connect to existing topography. So with that, we'll do this real quick so you can kind of see what needs to be done. Basically, remember, for the path, you start with the center line of the path. Don't draw a 6-foot wide path. We're just going to draw the center line. So what you want to do is from here, draw a center line up to your highest point. So if we just I'll just kind of wrap it around like this. Maybe come in here. We'll just come around like that. Alright, so I drew it in lightly. I'm going to erase. Just give me something to follow here. So this is just a light center line. And the way the center line would be just like a swell, just long line, short line, long dash, short dash. So I'm just drawing. Alright, so this is a little easier because now you can measure the length versus trying to draw a line that is exactly the right length. And then what we can do is, first thing we're going to do is measure how far this line is. This is the center line of your path that you just drew, and the way you do that, this is 30 scale. So 30 scales right here. Better scale. This one's kind of broken up. Let's use this one. So 30 scale is right there. You can see that 30 scale. Kind of. So 30 scale. 10, 20, 30. 30 scale. So to measure it, just take your ruler. And you can start from either the top or the bottom, it doesn't matter. And what I do is just kind of follow the pathway here. It's it went a little so bright. Let's see here. Let me do this. Let's see if this helps. Oh, it's the reflection on this scale. Hang on. Maybe that's a little better. A little better. So what I'm going to do is I'm just going to measure. See this? So roughly, I'm just going to go roughly 30 feet, put a little mark there, and then I'll keep the 30 right there and just rotate my scale. Go another, so that's to 50. Just working my way around this roughly. That's about 80 feet. And 105 feet. And then I just keep going, keeping my scale. So there's 125. And then I'm wrapping it around. There's 150. Keep going. That's 160. 160 is there. 175, 180, it's right there, go around to 190, and then 200, it's about 190, let's say 199 feet. So I just measured about 199 feet. So what do we know? We know what the vertical distance is, right? It goes from 38.2 and drops down to 32.9. So let's figure out how far that is vertically. So it's just 38.2 minus 32.9. That equals 38.2 minus 32.9 equals. So if I turn on my calculator, let's see, calculator's not turning on. There we go. Turn this back down this way. Solar calculator, and I have no enough light. 38.2 minus 32.9 equals 5.3. So it drops 5.3 feet from here down to here. All right, so now we know what the vertical distance is. Minus, just double check that, make sure I didn't hit anything. 5.3. So it drops 5.3. We know that it's 199 feet horizontally. So what is slope? So slope equals vertical divided by horizontal, right? So vertical 5.3 divided by horizontal, we measured 199 feet. Now we all should have slightly different configurations for your path, distances, and that's okay. Use whatever you measure that path out to, you use that. So I come up with 5.3 divided by 199, 0.266. 0.266. We'll call that a 2.7% slope. That's rounded, so 0.027. Forgot to put a, I wrote that down wrong. It equals 0.0266. So I just rounded up, made it 2.7%. So the slope of my path is going to be 2.7%. Maximum, so path longitudinal slope here is 2.7%. All right. So now what we've got to do is we can draw our 6-foot path. I'm just going to draw 6 feet, so it's 30 cells, so it's basically 3 feet on each side. 3, 6. So it's going to go roughly like this. Man, this is, I don't know why it's having a hard time with the video, but goes around. So this is one side of the path. Just draw carefully. And then the other side's about 3 feet. We'll just draw it in. So now we have a path that goes basically like this, all the way up. Now your path is going to look slightly different. It should. All right, so there's my path. And we said it's 2.7%. Our highest point is 38.2. It's going downhill this way. So where am I going to put the first contour? It's going to be 38, right? First whole contour, and it's going to be downhill, so 0.2 feet downhill. We know that horizontal equals vertical divided by slope. And the vertical is 0.2, 0.2. We'll divide that by my slope that I came up with, 0.027, and that equals, oops, you know what, I'm writing too low, you can't see what I'm writing. So horizontal equals vertical divided by slope. So in this case, 0.2, because it's got to drop from 38.2 to 38, right? Divide that by the slope, which I said was 2.7. I wrote that down at the bottom of my page, if you can see that right there. 2.7. Wrote it in that little, that's what you need to do as well. Write it in your on your homework page. So now it's 0.2 divided by 0.027 equals 0.2 divided by 0.027 equals 7.4 feet. So then just measure 7.4 feet along this pathway, and it's going to be right about 5, 6, 7 point right there. So let's call that, that's 38. So now we've got to drop a foot. So I'm going to use, and you can do this too, I'm going to use a red just to make this show. So that's red dot there. I'm going to do another one. Now we're going to drop 1 foot, right, and divide that, because we're dropping now from 38 to 37. Make sure these are 38, 37, so it is 1 foot contour intervals. 0.027 equals 1 divided by 0.027 equals 37 feet. So every 37 feet along that path is another contour. So I'm going to just measure 37 feet. So roughly, there's 15, actually 15, 35, 6, 7. So right here. I'm going to put it in red here. There's another mark. And I'm going to measure, now it's 37 feet the whole way. So I'm going to measure another 35, 6, 7, puts us right about there. Right there. And then measure another 37 feet, which puts us right about here. Right about here. 37. 37. Man, this is terrible. Let's see. Another 37 feet. 35, 6, 7. Right in roughly somewhere in here. Here, so we've got 38. Not 37. That's kind of 20, 35, so it could be a little further, so, but it's supposed to be 37 feet apart. It's hard to get it perfect on here if you're on the computer, because this last one is, this is 38, 37, 36, 35, 34, and then one more, 33. So this is 32.9, so it's going to be really close to that. So 30, 20, 30, somewhere in here, right in here. So I put a contour every 37 feet. So now just draw a light line. Remember from our earlier, if you looked at the last video, we showed you how to do the path. So just draw a light line perpendicular right across your path like this. So see that? So I drew those as guidelines. Now we've got to use that formula for the, remember this formula right here that you guys hopefully did earlier? 1/2 the path width times the path cross slope divided by the path longitudinal slope. So if we do that, half the path width is 3 feet, and we multiply that by, see here, multiply that by the cross slope. Cross slope is, path cross slope is 2%. So times 0.02 equals 3 times 0.02 equals 0.06, 0.06, and then we have to do that 0.06, 0.06, and that's divide by the path longitudinal slope, divide by the longitudinal slope, which we said was, for me, it's 0.027. And that equals, again, this is my number. Yours won't necessarily be the same. You draw the path how you want to draw it. But let's do 0.06. 0.06 divided by 0.027 equals 2.2. 2.2 feet. So what that means, if you remember from earlier, what that means is this side, now you got to look at your hill. This is 38, this is 37, so the hill's coming down this way on this side. So we want the path, because water's going to be coming down the hill this way, we want the path to drain this way as well. So that means my contours are going to, this contour, I'm going to measure 2.2 feet on this side. So like that, and this one 2.2, like that, and it's going to be, the contour is going across just like that. So you can see which way does it drain, right? The water's coming this way. If the water's coming downhill, the water will continue this way, right? That's why we want this at an angle, not going the other way, because if we're going the other way, it'd be going, the water would be going up the hill. Same thing here. So this one, right, we're going to want to turn it this way. So the water's going downhill, 2.2. Again, at 2.2. Right there. That's what we're doing. So basically 2 feet on this side, 2 feet on that side. Comes like this, cross. So that's that cross slope. See, we're getting the water to drain this way across. Same thing here. We'll do 2.2 and 2.2 is going to put it this way. Again, you've got to decide which way to do this contour so that it continues to drain across your path. 2, and then there's 2 right here. And this one, it's going downhill this way. So actually, if I did the path this way, yeah, it kind of worked that way. I think water coming down here kind of go. You could really go either way on here. I think I'm going to go, actually just the opposite. I'm going to go this way. So water drains across the path. So I'm going to flip it this way. So what I did is I just changed my mind and reversed it. So I'm going to go this way. Right, so the water comes across here, it'll go across. Now, the last one is going to be 2 this way, 2 this way, and it goes across like this. And again, it's going downhill, water will go across and flow this way. This is a tight path. It's kind of hard to make it, it's kind of a judgment call. So you guys, like here, it could go either way, this way or this way. So on those, you just look at it and try to logically think what's the best way for that contour to go. This one, I'm actually decided I'm going to do it this way. All right. So it drains off this way. It goes down the hill. So now this is contour 38. So 38 has to tie back into here, right? I'm drawing this in red so you can see it. And then from here we got to tie in 38, right? Tied in 38. Here, this is 37, contour 38. 37, 37 has to tie back in. So what I'm going to do is draw it like, just kind of that, this, oops, it's going to come up, 37 has to come up and around. that. So I got to tie back into 37, and this way it's draining off the side. Remember, this is the 4-to-1. It says 4-to-1 at the bottom of the assignment. So that gives you your guide for the maximum slopes 4-to-1. So just keep your contours at least 4 feet apart, which they are well. They meet that easily. So then this one is 37, this one's 36. So 36 has to go, actually 36 can't tie in here, right? Because this is 37, it's got to go around here. Right, so it's got to come kind of like this and tie in here. And then 36, it's like that. 37, you're going to have to bring it like this. So now it goes, see, 37 goes all the way around. But see how I had to bring that over, because this is a, you can see this kind of a, almost a ridge, a high point right here, so we have to grade that back. And then we've got to tie into it. It comes around, we got to tie into it over here. So we've got to come all the way around like this. Tie into 36. 36 goes all the way around. This is 35. 35 is going to come right through here. Tie into here. So our max 4-to-1. Remember, 4-to-1. So if I just may, I have to keep these. Look at that. That's 4 feet. That's 4 feet apart. So that's perfect. God, it's so bright. I don't understand what's this right. And then this is 35, so we got to tie 35 back into here, and we can just go 35. Kind of goes like this. Ties in here. But then look, 35 comes here. We've got to put over here. We got to take 35 around. There and there, and then we got to do 34 has to tie back into 34, which is right here, so 34 can tie in right there, and it'll tie in over here. Right, and see that that's 8 feet apart, so I'm fine with that 4-to-1 requirement that we have, and this is 3, so it goes 33, goes like that, and then has to tie into here, and then we will just look and see that doesn't cross, that doesn't cross, so everything's good. So this is, let's just label 38, this will be 37, and then we'll go 36, this is 37, and 35, and then this will be 34, 33. So there we just graded it. We have a cross slope of 2%. We have a longitudinal slope of 2.7%, which I came up with. And then we have all the contours tying back in, and none of them are crossing. See, we kept the 3 or 4-to-1 separation, and all our contours work. So, and we just did a little bit of grading around these trees, but not too bad. And that's it. That's the assignment for this week. And we'll go over this when I get back. So if you have any questions, hang on to them until we get back. But hopefully that makes sense. It's what we've been doing over and over, just figuring out what your longitudinal slope is, put your whole contour numbers, locate them on your path, and then just tie into the existing contours and make sure that nothing crosses. Like, see, this contour here goes around, and then it comes and it crosses under this contour. So we can't do that. That's why we've got to do a little bit of grading here to keep it away. And then this is 4-to-1 max. Per the requirements on your plan, 4-to-1 is the maximum slope.